Yeah, that's a look at what's happening out there. Looks like business as usual, and I'm not seeing any masks, PPE, or anything like that. Not really much social distancing. So, yeah, I just don't know. But I guess we're going to find out sooner than later what exactly is going to happen. Let's look around the weather in the southwestern U.S. We'll start out there. Looks like kind of a quiet weather pattern. Looks like a bit of a dry line there in Texas. We've got one boundary that is probably left over from yesterday. Let me draw that for you. So yesterday we had a boundary that pushed way out into eastern Oklahoma and East Texas, moved during the afternoon quickly eastward, and it didn't really advance back very much overnight. And it looks like we've got this new boundary forming today. So that's kind of how it looks right now. And you can see that the air back behind that dry line is very warm. Lots of lower 80s. And that confirms that this is a tropical air mass. If you want to go by the old Norwegian system, we would call that continental tropical air back there. And this would be maritime tropical. I kind of wish those abbreviations were used more. I like them. It's a good way of distinguishing the air mass types. May not fit in all situations. In the Central Plains, we've got a new system coming in from the north. There it is right there. Very weak, just a 1004 millibar system. And to the north of that, IFR conditions north of the warm front and southeasterly winds. And I don't know about this other system in Nevada. Let me go back out there. Pretty quiet in California. Kind of looks like an early summer pattern. Kind of a weak onshore flow and kind of cool. A little cooler up north. But the system in Nevada, I don't really know exactly if that's a cold front. My suspicion is due to the warm conditions down here in the Colorado River Valley, in the cool 30s and 40s, and that little snow there in the Austin, Fallon area. That's got to be a front. So I'm going to go with that for now and maybe put the Bear Clinic low there in Utah. Across the southeastern U.S., we've got a ridge extending from Indiana all the way down the lower Mississippi River Valley towards Louisiana. Still got that very lethargic outgoing low-pressure system off the Carolinas coast, that cold front moving through southern Georgia. And you can see behind that, temperatures fall off from very balmy mid-80s all the way down to 70s and 60s around the Asheville, Raleigh area. So much of that area in the Carolinas under the influence of that northerly flow. And in the Florida area, we've got a relatively dry westerly flow. There it is right there. And we can see it 87 degrees already around the Orlando area. In the northeast, we're still under the influence of that massive high-pressure area covering Quebec and Maine. There it is off the... Well, it's kind of off the edge of the chart there. Let me scroll that. See? Yeah, there it is over Maine. Cold 40s covering that area. And for the past several days, that's given us that persistent northeasterly flow across the northeastern quarter of the U.S. That is on its way out, although the ridge is still kind of hanging in there. But that's going to eventually start breaking down with these systems to the west. And one of them is that cold front moving through Ontario, Lake Superior, and Minnesota. So there it is right there. Weather back behind it, really not that cold. Just slightly below freezing, a few snow showers there around Thunder Bay. And that's being driven by this high-pressure area way up there in Manitoba. 27 there at Winnipeg, 24 at Grand Forks, and that's the leading edge of that air right there in Minnesota and the Dakotas. And here's how things are looking in the Pacific Northwest. A little bit of troughing extending all the way up to Wyoming to Montana. Conditions are pretty mild there. You can see lots of 40s and 50s there in Wyoming, and still a little bit cool up in Yellowstone Park with 27. But we do have this westerly flow, and that tends to be pretty warm in the spring. Looks like cool weather has returned to Oregon and Washington. We got 40s, and the clouds have returned once again, and we've got the flow being driven by this offshore Pacific high. See, there it is right there, that flow coming in from the north-northwest. So it appears we have cooled down a bit, and maybe that flow is even driving the Great Basin cold front to the south. But we'll take a look at the upper air charts. We we know for sure that there's a deep trough off here, maybe an upper level low. So what we got going on is probably a little bit of a reflection of that. I did get an email from one of my viewers asking maybe we should cover the forecast funnel and show how the weather is deconstructed. Well, y'all may not realize it, but I'm actually showing you how that's done. The weather has been pretty simple over the past few days, so we haven't had to go into too much detail. But I'm actually showing you how things are deconstructed here. So what we did is we went around on the surface chart. We weren't doing like a Weather Channel forecast. That was actually an analysis. We were looking around the country, seeing what was going on, and now we're going to switch to the hemispheric, well, this isn't the hemispheric, the continental zoomed out view. And what I've got on here is isobars, which is in black, and thickness, which is in red and blue. And I've said this a lot over the past maybe 100 episodes, but thickness is analogous to average temperature in the lowest 3 kilometers. So it's kind of like using isotherms, except we are not getting biased by stuff just happening at the surface. We're looking at a huge chunk of the air mass. So what that means is like this area right here in the Pacific Northwest, that's cold because there's this, everything up to the north, we know that that's cold. So the coldest thicknesses, the lowest thicknesses are up in this area. And then the tongues that extend southward like this, kind of looks like a thickness trough. That's kind of what it is. It's an axis of very cold temperatures. So that's a cold air mass. In fact, I could just go by that and put, well, what is this air mass? Maritime polar, if we want to use that Bergeron method right there. So maritime polar air coming in. And yeah, that's given us support for that front in Utah and Nevada. Now, there is another gradient out to the south. That's been giving us a little bit of trouble over the past few days. And I think that's because that's an old residual boundary. And then we've got this new boundary moving in. This is a fresh push of cold air. So I would still probably put the front way up here instead of down here, which many of us would be tempted to do. And possibly, see that little trough from Los Angeles offshore? That might be part of it right there. So that might be one big system like that. So I would probably look for a front in Southern California. Okay, what else do we see? So what we're doing is we're taking that surface analysis that we did. We're looking for consistency with the thickness field. Okay, so here, obvious front up in Canada. Okay, that's kind of goes without saying. This very weak front barely shows up. The data is not granular enough to really pick up the details on that, but it's definitely there. And then in the plains, yeah, if you were going to do it technically, we would put the warm front down here and do that like I said, but it appears there's been enough warm air advection, erosion that has probably pushed the front a little further north at the surface than we might expect. So yeah, putting that all together, I'm seeing a picture kind of like that. So that front being driven by the high pressure offshore, big Pacific high, and then this other front up in the Dakotas being driven by this other high here over Manitoba. And then a quick look up in Alaska. Let's look at that. Looks like a pretty powerful front up there. I don't know if you see it in the data. We've got Alaska here. We've got Yukon here. Let me switch off that little overlay. Let's see, how do we do that? Okay. Yeah, there we go. So, yeah, there is a boundary up there, and that's going to run probably something like that. The data is a little bit messy, but I think we've kind of got an idea. Yeah, it looks like a warm front extending down into Saskatchewan, and then probably an occluded front up into that low in Nunavut there. So what that tells me, maybe another push of cold air. See that high pressure way up here, northwest of Alaska? I think that's probably a new chunk of cold air that is moving southeast and will soon be into Western Canada in the days ahead. But man, that's a really powerful high off the Pacific coast. That's like something we would see in late spring maybe. Normally it tends to be kind of stormy out there, but these strong highs are mostly a summertime phenomenon. And it is really cranking there, and even Hawaii under the influence of that strong northeasterly flow at this time. So let's try something interesting. Let's try drawing a cross-section between the center of this cold pool in Nevada. Back that up to current data. Yeah, the center of this cold pool in Oregon all the way down to, say, Big Bend of Texas. Let's do a cross-section like that. So we're going to go to that weathernerds site. They got great cross-sections, and I talked to Matt Underlinde there. He works at NHC, so pretty exciting there. And this is something he does on the side. He says it's more tailored toward tropical, since his coworkers are always bugging him for stuff, but there's good winter and severe stuff too. And he's been very gracious about letting us use this. So we shall do it. So let's do that. Let's do that cross-section mode, and we'll go from Oregon to the Big Bend like that. See what it looks like on his site. Get cross-section. So it's always a good idea to confirm that your cross-section is set up the way you want it. And we can see in that inset we've got good feedback there. We go from A in Oregon to B in Texas. So there's A, Oregon, B, Texas, and it even gives us that lat long readout, which is very useful. So what are we looking at? Well, the black lines, those aren't pressure or height or anything like that. That's isotropes. That's basically a measure of temperature corrected to a common level. So wherever we have low values, that means it's cool. So right here, this is all cool air. See, lots of 286, 289. We can convert that. These are in Kelvin, so this is 13 Celsius. So if you drop it all the way to the bottom, 1,000 millibars, which is near sea level, say a parcel from right there, and sink that all the way down, it's going to be 13 Celsius by the time it warms up. So that's a good way to think of this. And if you take a parcel way up here, see it's 307, that means when you bring it down to 1,000 millibars, it's going to be 307 Kelvin, which is about maybe 100 degrees Fahrenheit. So yeah, bringing that down, you're going to get a whole lot of adiabatic warming. So what that means is that, well, I can kind of see a frontal surface, maybe in here. See how the lines are kind of packed together? Just as when you get packing on the surface chart of isotherms, packing here indicates a frontal surface. Not always, but very likely to be something like that. Now, that packing doesn't come all the way down to the surface. However, when it's horizontal like this, that's a good indicator. That tells us that we have a warm over cold situation, which is an inversion. So the lapse rates are very weak in that band right there. I don't see much in the way of fronts down in the low levels. See here, there's not much packing all the way down there. I think that front we were looking at in Colorado, that's probably it right there, maybe extending down, but the terrain effects, maybe convection kind of scrubs it out a little bit. Now, we're supposed to be able to get relative humidity on here. Matt did tell us that we can do that, so let's see how we do that. Display options. Okay, yeah, the trick to do that, I think I figured it out. You have to go to this model fields, and you go to moisture, and you pick any of the relative humidity values. Apparently, it doesn't really matter which one you click on. So, yeah, see, I clicked a random one, and it looks exactly the same. And this gives us the relative humidity, so we can use that to evaluate how close the atmosphere is to producing cloud cover, or if there's already cloud cover there. So, yeah, it looks like west of the Continental Divide, we've got a kind of a humid air mass there. Maybe it's a little bit trapped beneath the beneath it, kind of a weak inversion there, maybe. So yeah, maybe some of this higher RH is associated with that Pacific air mass. And then what we have here, that's probably more associated with the jet. So let's try another cross-section. Let's go from Winnipeg all the way down to Dallas. We'll do like a north-south cross-section. Pull that right up. And remember, the very first thing we do, we confirm, make sure everything's set up right, and it is. So this is Winnipeg, and down here is Dallas. Do we see a front? Yeah, right there. Start with the surface, and you can see how there's that gradient right in this area here. And boom, we hit it in South Dakota, Nebraska, and south of that, we're in the warm air mass. Maybe I need to change that around. There's our cold air mass, there's our warm air mass. And then the frontal boundary kind of goes up like that. However, what's going on aloft with the jet? The jet is not over this front, it's over the Great Plains. Well, we can kind of see what's happening. There's kind of a very broad cold air mass extending up to 400, 300 millibars, covering much of the northern plains and central plains. And it appears maybe the jet is responding mostly to that right there. Because if we go up to 500 millibars, I think we'll see a little bit of that discontinuity. And yeah, there it is. You can see from Texas, Oklahoma northward, we get that gradient and gradually transition into cold air over North Dakota. And that's enough to get things influenced in the upper levels. It's not just what happens at the surface that matters. It's also what happens in the mid-levels. And this is an example where the mid-levels are pretty important there. So it looks like maybe a bit of an upper air front. So just a quick look at heights and vorticity. Kind of a zonal flow across the central U.S. There's the polar front jet. And we've got this big trough coming into the northwestern U.S. There it is right there. Cold conditions aloft, and that's associated with that polar air coming in from the Pacific. And then over the next couple days, looks like by Thursday, starting to destabilize in the Rockies. The upper level low kind of parks itself there over Central California. Looks like kind of a showery day for the Los Angeles area. We can also see the subtropical high kind of building in the Gulf. So it's going to be a little bit warm around the Houston, New Orleans area. Then we start getting into southwesterly flow on the Great Plains, and this is when I start looking for the potential for thunderstorms around Friday or Saturday. Depends how much moisture we have and how capped we are, but there is potential definitely for Friday. And how do we find that area of interest? Well, we go from the trough axis, which is about like that, all the way to the inflection point. So we follow a contour, see how it's cyclonically curved. And then when we get about right there, it changes to anticyclonic curvature. The location where that changes is the inflection point. So that's going to be, well, a ridge is not the right way to plot that. That's the inflection point right there. So the ridge is right there. And then the trough axis out to the west. So anywhere between the inflection point and the trough axis, that's an area where we're going to expect to see the most destabilization and the most bad weather. So trough will be advancing out into the Texas, Oklahoma, Kansas area for Friday night and Saturday, and then into the eastern plains for the day on Saturday, approaching the Midwest very quickly by evening. So it looks like the bulk of the dynamics will be running from Albuquerque up to Chicago. That's going to be kind of the axis where we're going to get that bowling ball of lift rolling northeastward like that. So that'll probably stay mostly north of Texas and Oklahoma and affect mostly the central plains there. And let's put it all together. And so we don't drag this on too long, we're just going to look at the NAM, look at the next 3 days or so. So starting out, there's that cold front we analyzed up in the northern plains. We've got that other front up to the north, and we figured out that that's probably extending into Utah and then down to Nevada and possibly down through Los Angeles like that, into that trough you see right there. And I might actually draw that warm front kind of like that from Missouri up to Nebraska. Bit of a weak dry line there in Oklahoma, extending up to that low in the Hayes-Russell area. Outgoing frontal system in the North Carolina area. So that's the stage that we're set up with. Let's see what happens over the next couple days. Let's see, tonight, not a whole lot of change. The cold front in the Central Plains pushes a little further south. There it is right there. And then going into Thursday, this is how things look to me on Thursday. So there's a big upper level low over the California coast. Very deep southerly, southwesterly flow in Texas. Don't see a whole lot of precip breaking out, so either the moisture is shallow or there's a lot of capping. I guess we can bring up the forecast sounding and find out. Yep, yeah, there we go, capping. That's a pretty strong cap there. 850 millibar temperatures, 22 degrees. So to break that, what do we need? Let's check that out. I'm going to try breaking with a 14 gram per kilogram line. Break that back down. So we need a temperature of about 107 degrees Fahrenheit to break that cap. So it's not going to happen in Central Texas. Let's try going up to Oklahoma there. Cap's a little bit weaker, but we can see moisture problems. If we go with that 14 anyway, if we assume it advex up there, we still need maybe about 90 degrees Fahrenheit. So yeah, it could break if we go a little bit further north, but the model is not going for anything. Yeah, one little speck there around Pratt, Kansas. So looks pretty iffy. So for Friday, not much change. It looks like that cold front comes out of the southern Rockies. You can see that very strong band there in New Mexico. So it's definitely coming out of the high plains into West Texas. Still looks like the cap is a big problem. Let's pull up a sounding for around Abilene, Wichita Falls, Dallas. It looks like we've got some weakening, maybe with the approach of the trough, but there is some moisture erosion just off the surface. 14 grams per kilogram. We need afternoon temperature of about 92 degrees Fahrenheit, so that is still pretty problematic. So this is the 850 millibar chart, and if you look at that orange shading in Texas, that plume there is literally the cap. At least in this case, the 850 millibar layer is where it's most evident. And you can see that plume there, very warm temperatures, 25 Celsius moving across Dallas. And that's helping to keep things suppressed. There's another plume blowing up there over West Texas. And we don't really start eroding that until we get the upper trough approaching. So we're already up to Friday, and that cap is still kind of holding on, but as we get later in the weekend, you can see it starts breaking down as the northwesterly flow starts sweeping in. So if we have enough forcing along that cold front and it's unstable enough, we could get some forced convection. I don't know if the model's going for that. Let's take a look. Okay, so there's the front. This is early Saturday, about 4 in the morning, coming through Abilene and Fort Worth. By 9 a.m., moving into the Dallas area. Yeah, just not enough. I mean, you can see a little squeegee squall line there in southeastern Missouri and Illinois, but that cap has got things pretty much shut down all the way down to Texas, so it's going to be a dry front. Also want to let you know about the new schedule. This is what we're looking at for the next at least couple weeks. You can see Saturday and Sunday we're going to go to a supporters only show. I really have not done enough for the people chipping in on Patreon, and I'll give you the link if you want to be part of that and see the show on Saturday and Sunday. Before the show, Saturday and Sunday, you're going to get an email with directions how to view the show, and supporters can just go to that, and then we'll be back on the normal schedule during the week. So now's the time to do that Patreon thing if you want to help. If you find these programs useful, head to Patreon, and then we can keep investing time and effort into the show and hopefully teach you all something new. All right, that's about all I got for this evening. Thanks for watching, and stay healthy. definitely keep up on the social distancing and precautions. And we will see you tomorrow. Bye-bye.